So we're finally beginning our unit on astronomy. So this PowerPoint is going to have a lot of information in it because we really don't have a lot of time before the school year ends. And I want to get through it all because this is some fun stuff, especially once we get a little bit later into the stars and the solar system and the galaxy. So first we're going to talk about the Earth, the Sun, and the Moon, the main parts of our world. Now, of course, there's more than just our world out there, but this is the only world that we have human civilization living on. So we're all a bunch of big rocks in the universe. And the Earth is the third rock from the sun, basically. It's the big rock that has all of the nutrients that humans need, the oxygen, the water, the land, all of that stuff. And the moon is a rock that happened to start orbiting around the sun. And it orbits because of the pull of gravity. So, just like the Earth does with the sun, the Earth also pulls in the moon. And that's why it stays orbiting around us because of the pull of gravity. Now, if there wasn't gravity, the moon would just keep going because of velocity and inertia. And if there wasn't any gravity, it would keep going, but if there wasn't any inertia or velocity, it would just stay there in that one spot. So as Earth rotates, the moon would just stay in the same spot. But it doesn't because of both of these put together. Now, when the Earth rotates around the sun, we're talking the sun right now, we have four distinct seasons. And scientists didn't just make up these seasons. They didn't just say, oh, it's snowing, so we're going to call this winter. Oh, it's super nice out, so we're going to call this summer. No, this is actually a scientific thing because of the rotation of the Earth. Now, the Earth takes 365 and 1/4 a day to orbit the sun. So because of this fourth, that's where we get our leap year and they add in an extra day. So, for example, this year would be our leap year. Now, if we are looking into the seasons, it always falls on the 20th or the about between the 20th or the 22nd of a month, or 23rd, I guess. So right now we are in our spring equinox, and on June 20th we will turn into the summer. Now, our Earth is basically spinning and it takes 365 days to rotate fully around the sun. And one thing that's really important to know about this is we are only looking at the United States, North America, and South America, basically. So, right here would be us. Right here is South America, Brazil, Chile, all of those different places. Right here is Mexico. And we are all feeling the same exact season, although we might be feeling it a little bit differently. However, the people on the other side of the globe are feeling these seasons a lot differently. So you can see the tip of Africa there, but Australia is all the way on the other side of the world. So Australia, for them, their winter is in our summer, and our summer is in their winter. And they're basically opposite of us. So it's kind of interesting to think about. Now, our Earth rotates fully in 24 hours. And because of those 24 hours, the scientists have created a day. And basically, in one full day, every single spot on the Earth will reach a little bit of sun. Now, our Earth is on an axis, but it's a little tilted. So, because of that tilt, sometimes places like this will get a lot of light, where places like Alaska won't get any light. So, some days in Alaska, they only have 4 hours of sunlight. And then when the Earth is tilted a little bit differently, they have all day of sunlight and they barely even get any sleep. So that is also a very interesting thing about Earth's rotation. Now let's get into the moon. The moon has a 29.5 day cycle. And in that cycle, they go through all of these phases. So it starts out as a new moon. Basically, you cannot see the new moon. Eventually, it turns into a waxing crescent. So that little part starts showing up. And then it turns into a first quarter moon, and then a waxing gibbous. And the reason why it's called waxing is because it is getting larger. And the crescents look like crescent rolls. The gibbouses are the opposite, so they're bigger. And then you get into the full moon. Now they start waning, which means that they're getting smaller. I always think of waning as you're like weaning a baby off of a pacifier. So you're weaning them off of it, it's getting less and less. So waning is kind of like that. Now, the gibbous is again large, quarter, and then the crescent looks like a little sliver. And then you get back to the new moon. And there are websites, and we can look at one of those during class and look at how the moon phases are in this month. So they're very fun to look at. Now, you guys have all been alive during a solar eclipse that we've seen in North America, and that's really cool. These don't happen very often, and if they do, they happen all over the world in different places, but not here. The next one here is going to be in, I think, the 40s, maybe 19 or the 2040s. So very cool. And basically, a eclipse is where, or a solar eclipse is where the moon is in front of the sun. So all you see is the sun's light around it. And you have to make sure you don't look at this because it can blind you. The opposite of that would be called a lunar eclipse. And basically, the sun is there, and then you have the earth in front of the sun, and the moon is directly behind that. Now, the sun's rays basically go around the earth and pelt the moon, and they make it look like this blood red orange color. And it's really, really beautiful. I don't know how common these are. I have not seen one in my lifetime. Now, another really interesting fact about the moon is the moon controls our ocean. I don't know if any of you guys knew that, but actually the moon is the reason why our ocean has tides and waves. So basically, the moon has its gravitational pull. We already discussed that. That's the reason why it's stuck to us. And basically, that pull pulls the ocean towards it. So as the Earth spins, different areas have high tides. And on the areas that are not as close to the gravitational pull have low tides. So for example, right now in this image, the Australian ocean tides are really, really high. So people on the beach must be really careful of where they are at and where they're swimming so that they don't drown, basically. But eventually, it will spin and it'll be part of the low tide system, and part of the United States will be part of the high tides. And so this changes from day to day because of the moon. So, a little fun fact, we don't really have to worry about it, but people who live in areas with oceans do have to worry about it.